What's up, guys? Welcome back, and now we're going to tackle question 2 on this exam, which is, are the points P, Q, R, and S coplanar? And if not, we have to find the volume of the parallelepiped with adjacent edges PQ, PR, and PS. So how would we find out if these points are coplanar? I think the easiest way to do that is to convert them into vectors, and it already gives us the vectors that it wants for if they're not coplanar, so might as well kill two birds with one stone and make vectors PQ, PR, and PS. So vector PQ is just the coordinates of Q minus coordinates of P to find the change between P and Q. So it's 1 minus 1, negative 2 minus 0, 5 minus 3, which gives us the vector 0, negative 2, 2. We do the same thing for PQ, PR, and PS as well. I'm just going to skip the first step since it's pretty simple in mental math. So R, that's 3 minus 1 is 2, 1 minus 0 is 1, negative 1 minus 3 is negative 4. And for PS, that is 1 minus 1 is 0, 2 minus 0 is 2, 3 minus 3 is 0. So we have three vectors here right now, vector PR, PS, and PQ. So in order to figure out if they're coplanar, an easy property to memorize is that the dot product of two vectors when they're perpendicular is equal to 0 if perpendicular. And also, the cross product of two vectors, let's say C and D, gives you an orthogonal vector, which means that it's at a right angle, it's perpendicular to both vectors C and D. So how do we use this to solve this problem? Well, let's find the cross product of two vectors, say PQ and PR, and that'll give us a vector that is orthogonal to both of them. So to illustrate this, let's just assume that they're all coplanar. Let's just draw a plane out here real quick in 3D. It's not real pretty, but it just gets the point across. Let's say this is PQ, this is PR, and this is PS. This is assuming that they're coplanar, and this is only if they are coplanar. So if they're all in the same plane, that means that a vector that's perpendicular to PQ and PR, or orthogonal, would also be perpendicular to vector PS. And then we remember the dot product of two vectors, if they're perpendicular, is 0. So if we find the cross product of PQ and PR, we get the perpendicular vector. Cross product of PQ and PR, we get the perpendicular vector. Let's just call this vector E. I don't know, just first letter that came to mind. And that would mean that if we take the remaining vector PS and do a dot product of it with E, and it equals 0, that would mean that it is perpendicular to E, which would only be possible if all three of these vectors are coplanar. So now let's apply that with the vectors that we do have. Let's do the cross product of PQ and PR, and I'm not doing this in proper vector notation. I should be putting arrows over them, but let me just go ahead and do that just to make it a little bit clearer. A, B, C, D. Yeah, there we go. Boop, 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 boop. All right, so now let's apply this to the vectors that we do have, PQ, PR, and PS. Start, I'll take the cross product of PQ and PR. I'm going to go ahead and erase this just so that it's a little bit, I have a little more room to write. So cross product of PQ and PR, we'll start over here. Just write I, J, and K. For PQ, we have 0, negative 2, and 2. And for PR, we have 2, 1, and negative 4. So cross product, we have I, negative J, and K. For the I portion, it's as if we crossed out I, and then did the cross product of these right here, which gives us negative 2 times negative 4 is 8, minus 1 times 2 is 2. For J, cross out the J, and then cross product these ones right here, which gives us 0 times negative 4 is 0, minus 2 times 2 is 4, and then K, same thing, cross it out, cross multiply. That gives us 0 times 1 is 0. 2 times negative 2 is negative 4. So 0 minus negative 4, that's plus 4. Similarly, write that out as 6i minus negative 4 times j. So that would just be plus 4j plus 4k. It can also just be written as 6, 4, 4. So now we have the vector that's orthogonal to PQ and PR. All we gotta do now is test if it's perpendicular to PS with a dot product. So we do PS dot this vector here, 6, 4, 4, which is equal to the dot product of 6, 4, 4, and PS is 0, 2, 0, which is equal to 0 times 6 plus 2 times 4 plus 0 times 4. And that's pretty simple arithmetic right there. That's 0. That's 0. 2 times 4, 8. And that is not equal to 0, in case you weren't aware. So that tells us that all the coordinates given to us are not coplanar, because if they were, the vectors that we make with them would all be coplanar, and thus this right here would equal 0. So then what do we have to do? It says we have to find the volume of the parallelepiped with edges PQ, PR, and PS. Just erase this so I have plenty of space. So how do we find the volume of a parallelepiped in 3D space? As weird as that word may seem to say. Well, when you know it, all you got to do is a scalar triple product, which is equal to A dot product of the cross product of B and C. And when you know it, we already solved for PS dot product of that of PQ x PR. So this right here is the volume of the parallelepiped. 8 cubic units. And that's all. Hope you enjoyed watching and hope my explanation made sense. Thanks for watching and see you next time.